In this video, we're going to talk about summation notation. So let's start with the simple example. We have the summation of 2i plus 1 as I goes from 1 to 3. Before we get started, let's break down the equation a little bit. This is your counting mechanism. It goes from 1 to 3 in this particular problem. I know it starts from 1 because at the bottom of the sigma it tells me. And I know it stops at 3 because at the top of the sigma it tells me. So when you look at this problem, you know that I first is 1, and then 2, and then 3. So basically, first you plug in I equals 1, then I equals 2, then I equals 3, and you add all of them together. One thing you'll see a lot is a shorthand for when a function is inside of a summation. As an example, we have a function u of I, or u sub I, is equal to 2 plus I over 1 plus I. We could write it like this, but that looks a little messy and cluttered, so we'll substitute it by just writing u of I. That way, the sum is just u1 plus u2 plus u3 all the way up to u sub 25. Notice that we use the dot dot dot, so we don't have to write every single term. So we evaluate it in the same way as we did before. You find u sub 1 by plugging in 1 into u, then you find u sub 2 by plugging in 2 into u, and you add them all together. And if you're curious, the answer is 27.8544. So now let's go over some useful properties of the summation notation that you'll run into a lot. The first property simply says that you can take out a constant multiple out of the summation. The second property says that the summation of the sum is equal to the sum of the summations, or you can break up sums into multiple summations as shown. So let's go back to our original problem and solve it by using the properties we just went over. First, using property number 2, we know that we can break this up into two summations. Second, using property number 1, we know that we can pull out the 2 out of the first summation because it's just a constant multiple. Now we can evaluate each sum and get the same answer as before. You may be wondering, but this one doesn't have a counting mechanism. How can we do it? Well, think about it. In this particular sum, when I is 1, the argument inside the sum is 1. When I is 2, the argument is 1. When I is 3, the argument is 1. The argument is never changing, it's always staying 1. So every time I changes, the sum is just 1, 1, 1. So before we go, I'm just going to show some very useful formulas that we're going to be using in the next video. My next video is going to be about Riemann sums. And these are the formulas. The first one we actually just used in the previous problem. The second one we could have used in the previous problem. Go back and see if you can use it and get the same answer. The rest are just useful, and we will see them with Riemann sums. Thank you for watching.